Hello everyone, I'm Xiao Gang. Okay, what are we covering in these lessons? We'll still be developing within the sample project, and I'll share this project with you later. Okay, so let's first open our official documentation. Actually, for the next part, these two sections will just refer directly to the official documentation. We should now be covering other basic concepts, like interfaces, metadata, UFUNCTION, and some other things. Then we can reorganize and handle the subsequent content accordingly. Okay, so let's first look at the official documentation. For the official documentation, you can directly jump over from here. Then we'll first cover UFUNCTION. Then we'll cover interfaces and metadata diagrams. First, regarding UFUNCTION, we have already defined it before. The way to define it is with this thing below. Each declaration method is the same as the declaration method for C++ functions. At the same time, the above part also has two variables for modification. One is the specifier, the other is the metadata. Specifiers are used to specifically explain this function. Metadata is used for our editor for certain purposes. And this is its return type. This is the function name, then this is its parameter type. Then if you want to give a default value to the parameter, you can give it a default value after it. Usually you put this default value at the end. You cannot put the default value in the middle or it will cause a compilation error. And also this const determines whether it can modify some variable properties, etc. And this function specifier is this UFUNCTION. It can expose this function to Blueprint. That is, it's a way for Blueprint to call C++ code. And it can also perform many operations, for example, binding delegates. It also wants to respond to player input, send it to the network callback. Then this kind of operation is very frequent. That is to say, when we design a variable for network synchronization, then the user can receive the network synchronization code for this variable. You can execute them sequentially below. Then respond. We respond on the client to the synchronization request coming from the server. Okay, this part is a bit too formal in wording. So, let me expand on what each sentence means for you. UFUNCTION binding a delegate is essentially where will the binding occur. That is to say, we have a box. This box, it can overlap or when colliding. It will have a delegate in the blueprint. Let me show you. This will definitely be covered later. So if I just give you this article, expand it a bit so you can actually experience it. For example, let's create an act now. I'll delete this act later. And then here we add a box, a detection and box collision, and then here, the binding here. We generally prefer to use this. This blueprint should be used a lot. This delegate can be bound to the world settings. That is, the bound function must be a UFUNCTION, and their function signatures must have these parameters. So, what this sentence means is exactly that. Let's delete it. Then, this is related to some binding operations. That is our enhanced input. Perform some action bindings. We'll cover enhanced input later. It's in Unreal Engine. We'll finish talking about this take rate soon. Then maybe we'll cover string processing after that. We can go ahead and look at the official case study. Actually, it should be fine to look at the official case study directly now. Okay, last time we covered network callbacks. So, what exactly is a network callback in Blueprint? If you have developed a network game, you set a variable here. For example, let's set it as an integer variable. We consider it to be health points. These health points are definitely calculated on the server. Then, synchronized to the client's UI for display. Here, we use a replication setting, which is replicate only. Then we can create one here, and within our world settings, we can also perform such operations. We will demonstrate it to you in web development. So first, keep this concept in mind. Okay, let's continue and expand a bit. Alright. And then this. This is something we often use when creating cheat modes. We actually have something called cheat. We can enter some commands in the command line. Then through the Exec pin in Blueprint, after it recognizes the command, we can set things like infinite health. So that's what this sentence means. Then during development, we can call these commands. Yes, or we can implement some editor features. We can use this when doing procedural generation. All of these are acceptable. Then let's take a look at this function specifier. We wrote it into that code earlier. That is UFUNCTION, and these are a few commonly used pieces of code. Let's copy them. Then let me show you first. We'll explain them one by one. What do these mean? Okay, let's copy them first. Let's reproduce this diagram first. Then I'll demonstrate for you. Some things I want to explain to you. Here, let's add a class first. Add a favorite engine. Here we will use extra. We need to create a new folder. So let's call this one font type. Let's call it xtfunctype. Then after adding it like this, let's refresh it. Maybe some of our previously duplicated classes. Everyone can rename them. Just change the name. Let's try to avoid having classes with the same name. Actually, these things correspond one-to-one without blueprints, because the UEC++ code comes first. Then it goes through a series of operations through the blueprint suction machine. These things are then reflected into the blueprint. For example, you can then use them inside the blueprint, as for other scripting languages, like Lua and such, or that Perlis. It is essentially just interaction with Blueprint, the interaction between Blueprint and C++ code. The time difference is not that big. If you master Blueprint and Unreal Engine C++, then learning other scripting languages is actually very convenient. If they use scripting languages, it's mainly for hot reloading, for faster development, collaboration, and efficiency. But if you are a small team or a small studio, then using Blueprint is actually faster for us. Okay, let's take a look. It's already done. Then we come to this UActor. It has created a UActor for us inside. Then here we declare these methods. Actually, when we write code, we generally follow this official format. Variables go at the back, and the methods go at the front. And here, there are some extra things. It should be when using this markdown syntax, possibly some recognition issues. Okay, so these methods are all explained. So this place should be missing some numbers. Okay, let me check if it was missing when pasted. It should be missing here. Missing this place. Yes, alright. Actually, when you usually read the official documentation and find something unclear or problematic, you might be able to do this. You copy it, then here in our language settings, select English. Let's see what the original English version looks like. Let's check U dysfunction. Hey, is he gone? This directly gave the cultivator robe. Okay, let's check if there is a card called thankexing. If so, we'll ignore it for now. There should be a missing parenthesis here. There are also some extra tags. Then after we finish creating this, we can take a look at this part. This part is also wrong. There are some minor issues here, but they don't affect anything. This returns a default value of int. This generates full constructors. Then we'll check these four in Blueprint, not constructors, damn it. Or for a bees, this is the reflection function. Actually, if you want to take a look at the functions it generates and what they look like in this reflection, then you need to do the same as we did before. You need to go into this. and check what Blueprint functions reflection has generated for you and what they look like. We won't go into detail on that here. Similarly, let's create a new folder here to make it easier to manage. This is due to the input method. Sometimes when the input method involves Chinese, it will add an extra quotation mark for you. So it causes this kind of issue. This way we create a child of it. Pa, is this called actor? Maybe the name wasn't changed. Then let's change the name. Let's call it. As for this part here, we want to change the name. So how do you do it? Actually, it's best to do it this way. There's a bit of an issue creating this here. Let's copy this file. Then paste it here. Then paste the name here. Then just delete it directly. Then just change the name. Refresh it. Okay, then we directly refresh the project here. Yes, because if you operate like this, it can usually transfer correctly. If sometime you operate here, you will find that is you modify it in VS, but its actual position doesn't quite match. Okay, let's do it this way. Actually, we have already made the changes. Next, we just need to change this name. It didn't paste over like this. F2. Okay. As for the ones starting with A, okay, this area must be fully covered. This area is easy to miss. Like constructors and such, they are especially easy to miss. Okay, then this place. Okay, so basically the format is like this. Let's compile it. It should be fine. Completely. Okay, let's study that. Alright, we'll try to explain it in detail for everyone. After creating a paper type, we put it here. We still follow this strict naming convention. Okay, it's been created. Then, in our graph, how is this thing made? Actually, we'll demonstrate it for you in a moment. Here, in this graph, use the function names we just wrote. Let's drag it out and take a look. You'll see it uses BlueprintPure. This side as a pure function. Let's take a look at this one. This is a function with direct pins. Yes, and what about this one? Because it turns out that it is technically callable, but you modified it with const, which caused it to become like this. That is this function. We'll not modify the variables inside it. And this one, this means you want to prevent it from becoming like this. You add a force, meaning that although it is a constant function, that is, it does not modify the variables inside. I still want it to have direct pins in Blueprint, so I write it this way. Okay, next, I'll show you a common mistake beginners often make. It might look similar to the explanation here, because a pure function does not cache the editor, the cache result. So you need to be careful with large, heavy operations, and at the same time, avoid such host attributes. Now let me demonstrate. Let's clear it first. Okay. What I want to show is that, let me show you why it doesn't have a cached result and why it updates. Similarly, here we cubely can be placed. We first confirm it is a pure function, right? It is a pure function. We give it a name. Use a hard term to reflect it, called get. Should get the current available money, right? So here we have drawn a variable. We port it can protect the register, then this variable can be exposed to Blueprint or not exposed to Blueprint. Let's expose it to Blueprint. We give it a money. We set it equal to 10. Okay. Then what we need to do now is add this U property. For reflection in Blueprint, we just new blend readable, Blueprint read write, and also edit anywhere. Okay, we can categorize it or not. Let's not categorize it here. A bit less work. Okay, so this is one like that. Then we give it another one here. Let's call it pure gate. Pureable gate. Then this is for storing the gate. There shouldn't be any issues. Okay, here we return it. I'll return this value. The functionality of such a function is the same. But now let's write another function. If we write another function, let's also call it pure. We'll call it the kidmaster function. Okay, this part might be a bit confusing, but I think this example should be a good one. First, let's talk about what normal usage looks like. Okay, so here we get last. We make it so that after each use, we make it subtract equals 1. So it subtracts one usage count. And the same goes for this cooldown. That is, we make it subtract equals 1. We make it return. Okay, let me show you. Then okay, so here we create a new map. This is a blank level. We put it inside this U function. We call it function map. Alright, then we open this level bar. We drag an object in. We open an observation chart. And then simultaneously bring up its reference. Then we use an E keyboard here. Then we let it get money. We should not take this variable. We retrieve it through a function. We use the first pure get money and the first obligate money. Okay. Now let's print it. We mark this text in red. Print here. You might think this place, if you already know it. It might sound a bit tedious to you. But actually, many beginners make this mistake. They all make this mistake, including myself. I myself have made it several times. While debugging, after searching for a long time, it turned out to be this reason. It's just that maybe the memory isn't deep enough. You need to practice. Okay, so after this, now let's press 1 to execute. No problem at all. Now let's demonstrate the differences. Now press 2 careful POT 3TAT. If it's 2, we'll also use this kneel down action, but we are using this paying the get lattice pin. We'll have it print in red. Okay, how to debug these logs? We will explain this in detail separately later, so don't worry for now. You might say, I encounter a problem. How should I debug it? What should I do? Don't worry, because we are very detailed. Take it slowly. Or maybe here. Let them execute a few more times. Like when we press a key to execute, we press once and it executes twice. Let's execute it once more. Or rather, let me think about it. I'll execute it like this. To be precise, it should be executed like this. Observe carefully. When we press 2, observe the result. No problem. right? Oh, R9, punk. This caches the result. No problem. Now, if we are demonstrating the issue. What is this issue? What if we do it this way? What is your expected result? Tell me, what is your expected result? Isn't it? Did it subtract one extra time? So, here, what is it trying to tell you? Right? The meaning here is actually this blueprint node executed twice. If we do the same thing here again, we can take a look. You get what I mean, right? But can we avoid it? It should be possible. If we add a const when coding here, let's see if it compiles. It probably won't compile. See, adding const doesn't work. It prompts you that this modifies a variable inside. So this is a coding pitfall. Okay, now let's go back. We have already done this thing, this demonstration. We need to demonstrate what this is. BlueprintAuthorityOnly only runs on the G7 on the network front line. Execute from Blueprint code. This is very commonly used when developing online games. What does it correspond to? It corresponds to this. Let's just open a level blueprint. Write a damage here. Corresponds to this. This is the word. We use the apply node. Okay, right here. Then double click to jump. You need to install the debugging symbols and engine source code. You start the editor from VS and double click to find this function definition. What is this similar to? This is called gameplay static. This class is very useful. It provides us with some commonly used blueprint methods. These blueprint methods can be called in both C++ and Blueprint. And you will find that it can be used in Blueprint. So BlueprintCallable is completely fine. Do BlueprintCallable only. Then it has this mark in the upper right corner. Right. This mark is actually controlled through some metadata and some specifiers. This mark tells you that it can only be used on the network authority because we deal damage. Definitely, you can only deal damage on the server. So that's what the first sentence means. Then, it's better than nothing. It's a very simple reflection blueprint. Cosmetic means this function will only be used on the client side. In other words, dedicated servers cannot execute it. For example, if you want to update some UI on the client side, or if there are things that only the client should do, we can use Cosmetic. Look at this engine. Actually, it doesn't seem to use much of the cosmetic stuff. It just has a marker here. Let me check. Search for it. Because I'm doing a global search here. You can see. Take a look. This one is Cosmic. And this one? Why is this function marked as Cosmic? Because it's a dedicated server. What is a dedicated server? Dedicated. We have two types of servers in total. They are called listen server and dedicated server. Listen is a listen server. So its specifics, this should be explained in the networking section. But since it's mentioned here, we won't skip it. Let's start here first. This one is single player. No need to explain. This starts as a dedicated server. Then you connect as a client. This starts as a listen server. That is a main player. This main player is both the server and the client, while all other players are clients. Then on the dedicated server, we strip out audio rendering, and rendering all of these things. Because a dedicated server does not need to play audio. So after this function is modified, it can no longer run on the dedicated server. Then this BlueprintImplementableEvent and this BlueprintNativeEvent are ones we frequently use. It means here that this function is expected to be implemented in Blueprint. Here it is. This function is expected to be implemented in Blueprint, but we can also write it in C++. If there is no Blueprint, one to this part must be implemented in Blueprint. These two functions and the format they write must include implementation. Yes, and this Blueprint function is the default of this BlueprintCallable. We usually include a const when writing in C++, but if you don't include const, even if you write it, it is still a constant function, but it will cause problems. Then you can do this, but it will cause the problem we are currently demonstrating. But sometimes, even though it is a constant function, I still want it to have an execution pin, because we want the connections to look nice. Because if you connect it this way, it just doesn't look good here, right? If it doesn't look good, we won't be happy. Not happy. Then you can make it look like this. Make it into a situation with an execution pin. So this is the last sentence. Did we skip a sentence in the middle? Just these two sentences. These two sentences are very important. Very important. Let's take a quick look first. Let me write it down for everyone. So let's randomly click on an actor here. You'll find these functions. These functions that you can override. The essence is actually BlueprintImplementableEvent or BlueprintNativeEvent. For example, let's set up a hit here. Then double click to see if we can enter it. It seems we can enter it, right? Let me write one for everyone. This one needs to be written. If we don't write this, we're skipping too much. Let's just write one for this. Let's just use a paclick for a simple split. Actually, let's make it here. Let's give it an M03-012. Let's think about it. See if there's a return value. Let's write it like this for now. There should be actual code below these. Let's see if we can copy it. Its actual code might be inside this interface. Let's check the interface later. We'll talk about the interface later. Then we need to copy this. Let's copy the imply event first. Okay, then this place is called BP. We can pass a parameter. Generally, passing parameters here can be a bit tricky. Let's do it this way for now. I'll demonstrate it to you later. We pass a float, and I personally like to do it this way. In my float. Okay, so such a function. What does it look like in the graph? You will find that here, you shouldn't need to write the implementation. Okay, let's find our way. And then look at this place. Let me take a look. What was our name called again? BP only. Or here we... This is Coda. Hey, I want to rewrite it. Let me see. Let me see how to implement it. Found it. I was looking at the wrong place just now. It should be here. BP only master. Alright. Then you can call it parent class implementation. Then execute this value. Then you can see that this is how you override a function. Override a function. It looks like this. Then you can provide a default C++ implementation for him. So how do you provide a default C++ implementation? Actually, let's close it first. Then you have to write it like this. Let me take a look. Let me think about it. It should be here. Let's paste this over here. Right here. Okay. At this point, you'll find that it won't compile. Here we call it BP. BP and CPP must overwrite. Then you will find it probably won't compile here. Right, it reports this error. You report this error. Let's talk about this error. The link to 001 error. This is usually because either you wrote a function and it hasn't been implemented, often seen when we forget to write a constructor. or only wrote a function header, this kind of situation. Another situation is you introduced a type, this type of header file, or the module is not properly included. Then this function, why does it look like this? That's because of C++. Because for each function, it will go clutter and clutter, write a bunch of stuff for you, turning into these strange characters. This is C++. It has performed a equivalent to it doing it itself. Because this is due to the rebuild, it must give each function a function signature. It ends up looking like this. It tells you that this function was not found. Actually, we can implement it here. Then you will find that if you implement it this way, you still won't be able to compile it. Right. The correct way to implement it is you need to add an implementation. Implementation only has the implementation. This is your first time encountering. Later in the network, you will find many functions. All need to be done this way. Only then can you correctly be retrieved for interaction. Okay, we have an error here. So let's see what error it reports. Let's take a look. It shows that, oh, right here. Sorry, when did we accidentally press an extra S? It shouldn't affect anything. Okay, then it can be edited and passed like this. That is to say, for example, in this function, we can remove it. There is absolutely no problem. Then we can also remove, this needs to pass a float. We'll just pass a 0.1. This function is completely fine. You can also remove this function. It's also fine. Let's test it. Test it. So here we are. That is to say, you can remove it. You can remove it in C++. We of course call it in Blueprint. Door print is also quite convenient. Adding another layer in C++ is annoying. 0.5f. Okay, you can just remove it. But you cannot call this. You cannot directly remove this function. You must go through this uniformly, because it needs to retrieve whether it can find a blueprint override. If it can find a blueprint override, use the blueprint one. If no override is found, use the auto-generated code to call it. For example, here, we take this float. We add 10 to it. Okay, now let's call this function in the blueprint. We won't demonstrate the C++ call. We mainly interact with Blueprint, and I'll tell you later why it is designed this way. It's like this. We place an actor in the scene here. We directly implement this function in the actor. We directly call this C++ code. This function, right? Then we pass in a 1 here, so it should return the number 11. We have it print. Now we are in this observation view. We run it directly. Either, for example, if I want to override it now, I find this place. It is overridden here. I have it add another one. Add this value. We do not execute the parent class. Directly skip executing the parent class. Why? Sometimes we don't need to call the parent class. Let me demonstrate this for you. I'll demonstrate both methods. So now let's think about it. What value will it return? It will return 6, because it's 5 plus 1, right? That's correct. If we often call this, sometimes what you execute is not correct. You might not have called the parent class, because for some parent classes, you can simply ignore their functionality. And for some parent classes, you need to use their functionality. So it depends on whether you understand what you are doing. You only just found out. There's an error reported here. Take a look. I'll just add it directly here. So now we should be returning 16, right? Because it will add 10 here. Then you take this number and return it, because what we're calling here is add 1, right? Okay. Hey, 16. So that covers all the core concepts in this section for you. Basically, mastering it to this level is enough. We can take a look later. And here, there is a coactor. It can be used in our details panel. Let me demonstrate it for you. This is called the detail panel. We will demonstrate something called co-editor. Similarly, we make it public here, and we use a function. Let's name it Waven. We'll call it detail co-editor. we need to attach it here. Now we create an implementation for it. Then you can perform some operations in the editor. For example, if you click this, quieter, then randomly generate these 10 objects in the scene. Doesn't it look a bit like procedural generation? Let's enter this map. Okay. See, detail core editor, it hasn't been done. You can log things here, etc. None of these are a problem. Retrieve some related information about the instance. These are all quite special. Generally, after we access some editor features, we will often use this. Okay, so this client is in our network. Its usage method is similar to the previous one. This is actually somewhat similar, but their functions are different. It is mainly used for calling the client on the server. Code executed on the client. Caching is something we sometimes encounter with generics. For example, some generics. As for templates, for example, some template functions, for this kind of template, we need to do something like caching ourselves. And this execution pin is generally used with the command console. When you enter this command, in the command line, you will use this. We can search for it. We found it. Let me show you as much as possible. This definitely won't. There's definitely no way to guide everyone through this, because you're just starting to learn. There's too much of this stuff. This is better suited as a dedicated topic. It seems like it wasn't found. Then how about searching for it like this? It should be found it. See, these are some sheet commands. That's it. Notice that? This is how it's used. Usually we have a dedicated cheat manager, something like that, specifically for developers to debug. So here, just know that this exists. This is related to live snapshot. What is this? I'm not too sure about this either. It seems to be performing. You might be capturing something related. Okay, this is broadcasting. This is used in online game development. Okay, this is related to web and unweb. They are. This is your RPC remote call. This is the server requesting the client. The client requests the server. Does it need to be reliable? If it is reliable, then it will definitely arrive, but the performance or speed might be a bit slower. But if it's unreliable, then just ignore it. So how do we distinguish between these two during development? That is, if a piece of data needs to be synchronized at all times, then I should use unreliable, because losing 1 or 2 packets doesn't matter. But if there are some critical operations, for example, when I set 偷子结算, or when I complete this level and I need to send rewards to the player, then this must be reliable. This request, these sale events and such, I don't think I've used them much, so let's not mention them. Then this sale means the client requests the server. We'll use this function to mark and use it. This VSVD means also when making a request, we'll perform a check. That is, first check whether this request meets the standard. If so, we only then proceed with subsequent operations. That is to say, if you are using this network request, you will find that it may have too high latency or deviate from our expectations. Then it might be problematic. You can throw. BT8, then we hit something like force. Just discarded it. As for this metadata specifier, we've talked about it before. This is advanced play. Do we need advanced pins or something? And this is the number of the advanced pin. Because you see some of our functions, we often just take the simplest example. Span actor. You see, this is an advanced pin. This is a little blueprint tip. Okay, no problem. These are some wildcard things. We will mainly show some of the things we will use. These are some nodes. We can directly look at this part. Take a look at this latent one. This latent one is quite critical. Usually, it is commonly found within the engine source code. That is, if you look at this delete, you will find its writing style. You will see that there is a quable here, no problem. This is the world context. When this variable is called in Blueprint, we will assign it a world context object. Therefore, when calling from Blueprint, you won't see this pin, but right. However, at the same time, it has the latent action info. This info will capture some contextual information. Then this places for assigning a default value to it. These are some keywords, so you can compare and check them one by one when you need to use them, or one day you think of whether there is such a function. When I want to use it, you can come back and look up this table. Then this is out. This can be used as some modifiers for function parameters. Haven't used it much. We'll talk about delegates in chapter 17 later, because I prefer to add in and out to the function name to distinguish them. We almost missed the key knowledge point here. That is to say, let's turn it off first. So here, actually, we have a function we can attach. There's a special way to write it. We usually write it like this. We call it getHealth. Get. We give it get body. This. So here, this lesson is getting a bit long. Let's wrap it up quickly. There are several ways to write this. This is called const. We IntelliSense 2, in my number, we need to write it like this, usually written like this, in my number. Then there is another way of writing called IntelliSense 2, out my number. Then we can indicate, then our intersensor. We still use intersensor like this in no more number. Okay, let's go implement it. Okay, then here, we enter the difficult street side. We find inside the event graph, we can see here is a get status. We shouldn't use status. You can see, you will find these two are used as inputs, and this one is used as an output. This one is the return value of the function itself. And actually here, according to our standard specifications, you can write comments. Comments will also be reflected above. So roughly, this is the place that needs attention. And at the same time, there is another detail to mention. When you pass the container, if your variable is a container, you might encounter this issue. This issue is that when you clearly give it a container with a capacity of 5, after you pass it, the server side does not receive it. Actually, it's not the server. The C++ code here does not receive it, or the C++ code does not modify this container. Then when you go back, you will find that this host in N2 has, at this point, you may need to use this uparam. Use this uparam like this. This turned red. That means you need to pass this retrain. That's roughly what it means. We'll talk about it later when we use it. Here, we can simply give it a try. Yes, let's give it a try. We'll cover this in this lesson. I kind of forgot how to write it. Let's take a look. We'll just pick one. Anyway, there is a pitfall here. Let's write it out. Okay, I'll quickly write a simple version first. That is, we will pass in some data, then add a 310.2 to this data, and now let's first write an incorrect version. For example, let's just do it like this. We won't pass the reference. Right here. Good, okay. Actually, it's not exactly a wrong way to learn. It's just that doing it this way doesn't actually meet your needs. That's roughly it, okay? Now let's simply execute these two. Alright. We can set a bet. That should be fine too. Okay, then here, we put it here. It should be called body array. It's here. Alright, we also have a body array, right? So both of them will operate on this array. So if we want to test it, we'll use begin play to test it. This makes it more convenient. Yeah, I don't want to write too much logic. Then I'll pass an array here. We'll pass an array here. Okay. We'll give it some default values. This lesson is a bit long. I'll try to speed it up. We'll give it 1, 2, 3. Give it 3 default values. So we hope that after it finishes executing, the values in this array will change. Then we'll let it loop, have it print out each value. Anyway, there are indeed pitfalls here. This is something I realized during actual development. I've seen many people make this mistake, so I must specifically emphasize this point to you. Take a look. 120趟. No problem, right? Let's take a look. 1000-TT40 seems to have a bit of an issue. What about executing the one below? This function can only be done this way. Let's first execute the effects of these two. You can just drag it over like this, okay? Take a look. You will notice there's a problem here, right? Okay, I've debugged it. I realized I keep making mistakes. Let's first take a look. The correct result I want to show you. No problem. Then let's take another look. As for the correct result, let's switch over again. The blueprints are all the same. They are all the same. See, this one only has 102, 3. So where is the difference? The difference is right here. Here, this U permit. Here we missed a reference just now. Missed a reference. This part should have been written like this. Okay, so for this U permit, we'll briefly introduce this part to you. Everyone will know once they use it. Then, when you pass it, you'll keep thinking about it. That is, whether this thing can be correctly passed to C++, whether C++ can correctly return it back to this blueprint. Of course, you can pass a copy. This is completely fine too. But sometimes we also want to make a modification based on the original value. If you return a value here and then copy that blueprint again, this is quite costly. Okay, this part about was a bit long, but we should have covered most of the features you can encounter in UFUNCTION. For you. Then we are also simultaneously in this UFUNCTION to help him understand some commonly used nodes, and actually most of the time, we still need to practice more. Maybe delegates and some topic content hasn't been covered yet, but we will cover it later. Delegates are mainly used for this binding. Timers should be used as little as possible, because timers are actually quite good. Alright. We'll stop here for this lesson. Everyone take a good look at this. Next, review it more. Thank you, everyone.